All right, guys, we're going to go over that radicals quiz review. So again, the quiz tomorrow or today, depending on when you're watching this, is exactly the same thing, just going to have some different numbers on it, okay? But if you can work through all these problems, you'll be just fine. So I appreciate you tuning in and to the study guide, and good luck tomorrow, okay? Now, our first question, we're asked to find the domain. So our question is, find the domain of y equals the square root of x minus 1. All right, now domain, just remember that the reason for this is because we're trying to make sure that whatever is underneath the radical sign is not a negative number. So to do that, we take what's under the radical sign, which in this case is x minus 1, and we set it up greater than or equal to 0. We just solve this for x, and then we'll have our domain. So add 1 to both sides. This leaves me with x greater than or equal to 1. So this is my domain. Okay, now remember the reason for that is because the only x values that would work in this function are values that are greater than or equal to 1. For example, if you plugged in 1 for x, you would have square root of 1 minus 1, which is the square root of 0, which works out fine. There's nothing wrong with that. But if you plugged in something less than 1, like if you plugged in negative 1, that wouldn't work because negative 1 minus 1 is negative 2, and we cannot square root negative numbers. So that's the reason for the domain. But all you really have to do to solve it is take what is underneath the radical, set it up the same way every time, which is greater than or equal to 0. Once that's happened, you're good to go. So number 2 is same thing, but it's a little bit more fancy. Y equals 7, square root of 2x plus 4 minus 5. So keep in mind what I said in the last problem is the same thing here. You only care about what's underneath the radical. You don't care about the 7. You don't care about the 5. We're only asked to find the domain. So we just want to make sure that whatever's underneath the radical is greater than or equal to 0. So we're going to take this 2x plus 4 and just make sure it's greater than or equal to 0. Okay? So solve this for x. That would be subtracting 4 on both sides. 2x is greater than or equal to negative 4. And then divide by 2. We have x greater than or equal to negative 2. And that's your domain. And if you want to make sure that it works, just pick values for x and plug them in. And as long as you don't get a negative number in the radical, you're all set. If you want to plug in numbers that don't work, then those numbers would have a negative under the radical. Okay. Now remember, the only thing with these problems, and I'm not sure if it's on the test or not, is if you ever divide by a 0, or not divide by 0, divide by a negative. I don't in this example, but if I did, you'd have to flip the sign. So that doesn't happen here because I divided by a positive 2. But if you do divide by a negative, you would have to flip the sign. Otherwise, it's the exact same process. All right, so number 3. We're simplifying the square root of 100 over 4. Now, there's a couple things you could do. There's 2 ways you can go about this. You can either separate these out and do the square root of them individually, which the square root of 100 is 10, and the square root of 4 is 2, and 10 divided by 2 is 5. You get the answer that way. Or you can simplify the fraction. 100 divided by 4 is the same thing as 25, and the square root of 25 is 5. So it's the same answer either way. It doesn't really matter how you went about doing it, but either would work. There is one that works out this way on the test. You'll have perfect squares. It might not be 104. It might be like 36 and 9 or something. I don't know. But you can do it with either approach, and you still get the same thing. But remember that rule that you can separate a division problem like this into their own radicals. Okay, but also remember that it might be easier to simplify it first and then do the radical. It's up to you. So number 4, square root of 9, a to the 5th, and b to the 16th. So what we're going to do is separate each of these into their own radicals. Okay, and I'm going to do all of them onto the side here. Now the square root of 9 is a perfect square. That's just a regular 3. Nothing really special about it. Square root of 9 is just 3. So I'm going to convert that to 3. The square root of a to the 5th, that's a little bit more interesting because if it was an even exponent, it'd be easy. I would just take half of it. But it's not an even exponent, it's an odd exponent because the exponent's 5. So when you have an odd exponent, you split the a to the 5th up into the biggest even number that comes before 5, which in this case is 4, right? And then that 5th a. So you always split it up when it's an odd exponent into 2 parts. One part being the biggest even number right before that odd number, and then you have that extra or that odd leftover variable. Now, if you do these one at a time, the square root of a to the 4th and then the square root of a, you do them separately. The square root of a to the 4th is a normal a to the 2nd, and the square root of a you can't really do anything with, so it stays the square root of a. Now, keep in mind that this is not the square root of a to the 2nd. It is just a to the 2nd, okay? And there's nothing more to simplify it because it's no longer in a square root. So that is as simplified as it gets for the a's. Now for b to the 16th, thankfully it's an even number exponent. So those work out pretty well, pretty easily. All you have to do to take the square root is just half of the exponent. So the square root of b to the 16th is b to the 8th. And that's it. You're done. It's not the square root of b to the 8th. The square root is gone. Once you've done the half exponent thing, there's no more square root. Okay? You're just left with the b to the 8th, the normal b to the 8th. So all 3 parts simplified here. This is my answer, but let's just rearrange things. Usually we write the radical thing at the end. So the 3 a to the 2nd, I'll move the b to the 8th up to here, and then I'll write the square root of a at the end. It's not a big deal, but it is kind of how you'll see it most of the time. So it's the same thing, except just rearranged, where all the things that are outside the radical are written up front, and then the radical is written last. Number 5, simplify the square root of 32, x to the 11th, y to the 4th. So we're going to treat this the same way we treated the last one. We're going to separate these into their own parts. Square root of 32, square root of x to the 11th, square root of y to the 4th. So I'll do them off to the side again. Square root of 32. Now 32 is not a perfect square. Remember, the perfect squares are 4, should write this, 4, 9, 16, 25, 36, 49, 64, 81, 100. These are probably as much as we need to know. 32 is not one of these perfect squares, but 32 is divisible by one of them. Well, it's divisible by 2 of them, but the biggest one is divisible by 16. So break 32 into 2 parts. 16 times 2. 16 times 2 is 32, but we're using 16 because it's a perfect square. So if you simplify each of these one at a time, the square root of 16 is 4, just a normal 4. And the square root of 2 can't be simplified anymore. So we leave that inside the radical. So there's your square root of 32. It's 4 square root of 2. The square root of x to the 11th. So this is a good comparison to the a to the 5th we did in the last problem. Because it's an odd number exponent, you have to split the x to the 11th into 2 parts. The biggest even number before 11, which is 10, and then the extra x. So when you separate these and you do them individually, the square root of x to the 10th, because it's even, is a perfect square. So you just take half of that 10, and you get x to the 5th square root of x. So the square root of x does not simplify, it stays square root of x. But the x to the 10th simplifies into x to the 5th. So remember, once you do the square root's gone. There's no need for it. So once I've taken the square root of x to the 10th, I'm left with just a normal x to the 5th. So let's write that back in the problem. We have x to the 5th square root of x. And then the last part is y to the 4th, square root of y to the 4th. And again, that's an even exponent. So all I have to do is take half of that exponent, and I get y to the 2nd. And that's it. The square root's gone. It's just y to the 2nd. So here's my answer in 3 different parts. Let's just put it all together. So everything that's outside the radical, which in this case is the 4, the x to the 5th, and the y to the 2nd, we'll write all of those in front. So the 4, x to the 5th, y to the 2nd, and then everything that's inside the radical, which is the 2 and the x, we'll write that at the end, and we'll put that inside the radical. So square root of 2x. So again, these are the same thing, but this is a more cleaned up version. Number 6. Number 6. So we're simplifying the square root of 176. So remember, we're looking for a perfect square that goes into 176. So here's a bunch of perfect squares. I don't think we'll need anything bigger than that. So let's see which one of those will divide into 176. I'm going to start kind of big first and work my way from there. So I'm going to try 176 divided by 64. Let's see, because 64 looks like it might work. So let's try that. 176 divided by 64. It does not work. So I'll try something else. 176 divided by 49 does not work. 176 divided by 36 does not work. I know 25 doesn't work. 176 divided by 16, that works. So 176, we can break this into 16 and 11. 16 times 11 makes 176. So I split it up, and I do the square roots of each of these one at a time. The square root of 16 is 4, just a normal 4, and the square root of 11 cannot be simplified or broken down anymore. So that is the answer. Number 7, square root of 25 x to the 5th over 36x. Now, before I break everything into their own radicals, I notice that I can cancel out these x's. I have an x on the bottom and 5 of them on top. So that x will cancel with one of those x's up there, and now make that x to the 4th. So this new problem is really 25x to the 4th and 36. So just cleaning it up a bit. Now I'll break all of these into their own radicals. So square root of 25, square root of x to the 4th, and the square root of 36. Now, all of them are perfect squares, so that really simplifies nicely. The square root of 25 just becomes 5. The square root of x to the 4th just becomes x squared. And the square root of 36 becomes 6. And again, there's one just like this on the test tomorrow. I mean, they're all just like this on test tomorrow, but I mean, in the fact that these are all perfect squares, that's no coincidence. That'll probably happen as well. But there's your final answer, 5x squared over 6. Number 8, the square root of 81 over 7. So this one's a little bit different than number 3. Now, first and foremost, 81 divided by 7 is a fully reduced fraction. I can't simplify that fraction anymore. So what I'll do is I'll separate the 81 and the square root of 7. Now, I'll clean it up a little bit, but I still have a little bit of work to do. I know the square root of 81 is 9, and the square root of 7 is still the square root of 7. Now, the problem with this, though, I'm just going to write it back down here, is I'm not supposed to have a square root in my denominator. That's the issue. So what I'm going to do is I'm going to multiply this by the square root of 7 over the square root of 7. Because this is still technically 1, so I'm not changing the value of the problem. But at the same time, when I multiply these two pieces at the bottom together, it'll make a perfect square, which will make the radical in the bottom disappear. So on top, I have 9 times square root of 27, or square root of 7. So that's just 9 times square root of 7. Simple as that. You can't multiply the 9 with the 7 because 7 is inside a radical and 9 is not. On the bottom, 7 times 7 is 49, so you have the square root of 49. So to clean this up, 9 square root of 7 is just fine. Nothing I can simplify there, but square root of 49 is a normal 7. And that is the final answer. So remember, you're not supposed to have radicals in the denominator. So if you get a radical in the denominator and it doesn't simplify, you've got to go through this process here to try to make that perfect square so the radical is no longer in the denominator. Number 9. 3. I want to use blue. I don't like this color. All right. We got 3 square root of 6 minus 5 square root of 6. Now notice we're subtracting. Now when we add or subtract, the only way I can add or subtract these two terms is if both of them are like radical terms. Both of them are like radical terms because they both are just square root of 6 terms. So that means I can just go ahead and subtract. 3 minus 5 is negative 2. So I have negative 2 square root of 6 as my answer. It's basically the same as 3x minus 5x. 3x minus 5x would be negative 2x. So instead of x, it's the square root of 6, but it's the same idea. But remember, they have to be like radicals to combine them. So number 10, we have 5 square root of 24 minus 5 square root of 54. Now, this is different because these two terms, although they look similar, they have different radicals. The square root of 54 is not the same as the square root of 24. So I can't just subtract these. What I need to do first is simplify them. So let me focus on this 24 here. 24, I can break that into 4 times 6. And if I work the whole thing out, square root of 4, separating the 4 and 6, I have 5 times 2, right? The square root of 4 is 2. And the square root of 6 doesn't really change. It stays that way. So that's going to be 10 square root of 6. Let's see what happens with the other one. Now 54, I can break that into 9 times 6. 9 is a perfect square, which is why I chose 9 times 6. Remember, when you're simplifying the number, you're trying to find what perfect square goes into that number. So 9 is the perfect square that goes in the 54, which is why I used it. So we have 5 times the square root of 9, the square root of 6. Now the square root of 9 is 3, so this is 5 times 3, and then the square root of 6. And 5 times 3 is 15. So we have 15 square root of 6. And don't forget, we are subtracting this. So now, it's kind of like the last problem. These are both like radical terms. They both are a square root of 6. So I take 10 minus 15. I have negative 5 square root of 6. That is my final answer. Number 11, we have the square root of 2 times 5 plus the square root of 2. So keep in mind that we have to distribute here. We're going to distribute the square root of 2 times 5. So when I multiply the square root of 2 times 5, I just have 5 square root of 2. Because remember, 2 is inside the radical and 5 is not. So I can't multiply the 5 with the 2. I simply kind of write it out. 5 times the square root of 2. Now, when I distribute the square root of 2 times the square root of 2, bring that plus sign along, I can multiply the 2 with the 2 because they're both inside the radical. So 2 and 2 make the square root of 4. So keep in mind that there's no like radical terms here. I can't combine this with this because the square root of 2 is not the same as the square root of 4. However, the square root of 4 can be simplified. The square root of 4 is the same as 2. So this is my final answer because I cannot combine the radical 2 term with a normal 2. Those are not like radicals, so I can't add them together. That is as simplified an answer as I'm going to get. So remember to distribute. Number 12. Number 12 is the same process as number 11. It's just you have to basically double it up. So we have, I'll just save room here. I've got 3 plus the square root of 6 times 5 plus 3 square root of 6. Okay, I could probably make this look a little bit better, but it's okay. So remember FOIL, okay? Multiply the first term together with the first term. So 3 times 5, that's going to make 15. And then we'll do my outer terms, O, which is 3 times 3 squared is 6. Now keep in mind that 3 and 3 are both outside the radical. So I can multiply that 3 with that 3. I cannot do anything with the square root of 6, though, but it kind of just comes along. So when I multiply 3 with 3, I get 9, and then the square root of 6 is there to tag along. Now I'll do my I. So my I is my 2 inner terms. So that's going to be square root of 6 times 5. So square root of 6 times 5 is just going to be 5 square root of 6. And then my L, my last term. So that's the square root of 6 times the 3 square root of 6. Now notice the 3 is on the outside. It has nothing to partner up with. So that 3 is still going to be there. Okay? But the square root of 6 and the square root of 6, both of these 6's are on the inside, and both of them then can be multiplied together. So 6 times 6 makes 36 there. Now, be careful on this because there's some fancy simplifying that's going to go on. I'm not going to do anything with the like terms in the middle yet. I'm just going to leave them alone for now. I'll add these terms in a second. But I'm going to focus my attention on this last term. The square root of 36 is 6, right? So really, this is 3 times 6, which is 18. So this whole thing on the end there just becomes 18. Now, I'm going to go ahead and combine these two terms in the middle. They are like radical terms because they both have the square root of 6. So 9 plus 5 is 14. So that's going to be 14 square root of 6. I'm going to lower this plus 18 for a second. All right, and then this 15 is still sitting over here as well. So I hope you understand where that 18 comes from, because remember, the square root of 36 is 6. So I'm just simplifying that, and then I'm multiplying it with 3. When I multiply it with 3, I get 18. So now all I got to do is combine some like terms. 15 plus 18, those can be combined. 15 plus 18 is 33. So we get 33, and then we can bring down the 14 square root of 6. All right, I had to drink some water there. It's getting tiring. Okay. There's your answer on that problem. Moving on to number 13? We got. All right, now we're just solving. So we have 15 square root of x equal to 45. So we're solving for x. So remember, we focus outside term first, then we solve the radical, and then we do the inside the radical last. So outside the radical is 15. So I'm going to get rid of that first. Now it's 15 times the radical. So to get rid of the 15, I need to divide it. So dividing 15 will move it, and we'll have the square root of x equal to 3, since 45 divided by 15 is 3. And now, to get rid of the square root, I would square both sides. So that's going to leave it as x equal to 9. And just to make sure that that is the answer, I'm going to plug it back in just to see that it fits. So 15 times square root of 9 equals 45. Let's see if that checks out. So square root of 9 is 3. So it's really 15 times 3 equals 45. And 15 times 3 does equal 45. So it does work out. It does make sense. Let's solve number 14. We have 2 square root of 9x minus 2 minus 3 equals 5. So remember, let's focus on the outside stuff first. And I can't spell, but that's okay. So outside the radical, I've got the 2 and I've got the minus 3. Now, I always take care of the adding or subtracting first. So I'm going to do plus 3 to move this 3 first. That's going to leave me with 2 square root of 9x minus 2 equal to 8. Now, I still have that 2 on the outside, so I still need to get rid of it. Now, remember, it's 2 times the radical. So I'm going to divide by 2 to get rid of it. that will leave me with the square root of 9x minus 2 equal to 4. So now there's nothing left outside the radical. So now I'm going to do the radical itself. I'm going to get rid of this radical by squaring it, right? And that just removes the radical sign. So now my equation is just 9x minus 2 equal to 16. So it's a pretty normal equation. You add 2 to both sides. You'll have 9x equal to 18. And when you divide by 9, x equals 2, because 18 divided by 9 is 2. It's probably worth plugging in this 2 for x and seeing if it all makes sense. But I'll let you guys do that because I want to keep the video short. I'm going to just move on. So number 15, we have the square root x plus 3 divided by 4 equals to 1. So outside the radical, we have this 4. So to get rid of this 4, since I'm dividing it, I'll multiply by 4 to both sides. That will cancel that out, leaving me with just the square root of x plus 3 equal to 1 times 4, which is 4. So now there's nothing left outside the radical, so I'm going to go ahead and remove that radical. I'll square both sides. That removes my radical. Leaves me x plus 3 equal to 16. And now it's just subtracting 3. So that gets me x equal to 13. And plug that in just to make sure it works. It should. There's your answer. All right, now number 16 and 17 are very special problems. They're not really, I don't know if I would say they're hard, but they're different, that's for sure. So let's write down the formula first. A equals, for number 16, A equals the square root, and it's S. Trying to make my S's not look like 5s here. S times S minus A times S minus B. Gotta make this longer, times S minus C. That's our formula. Now it tells us that the area that we're talking about, area of the triangle, is 20 meters squared. So area is 20. There's no reason to write the units down. You don't have to put the meters squared in this problem. Okay, just use the numbers. We'll worry about the units later. But the area is 20 meters squared. So I'm plugging in 20 for A as the area. Now, S is equal to 8. So everywhere I see that S, I'm going to write 8. So I'm going to have 8 there and 8 here. And let me plug in the A and B as well. A is 3, so that'll be 8 minus 3. And B is also 3. So I'll put 8 minus 3 there. And now I still know that S is 8, but I do not know what C is. That's what I need to figure out. So I just plugged in all my numbers. Now, I know that this 8 minus 3 is 5, and this 8 minus 3 is 5. So I'm going to write that back out. Let's simplify a little bit. We have 20 square root. This will be 8 times 5 times 5. And then I still don't know what this number is over here. That's C value. So I'll figure that out in a second. Now I'm going to go ahead and multiply 8 times 5 times 5. That is, I believe, 200. So this is 220 equals square root of 200. And don't forget that 8 minus C is still just lingering around right there. Okay. I'm running out of room here. How do I do this? Okay. So I'm going to erase this, but I'll pick up where I left off here. Okay. With the 20 equals to 200. And then 8 minus C. 20 equals square root 200, 8 minus C. Now, if you want to, there's a couple ways you could go about this problem. But I think what I would do is treat it just like a normal solving problem, kind of like 13, 14, or 15. Everything is inside the radical. So if I want to, I can square both sides and I can remove this radical sign. So that would mean 20 squared, which is 400, equals 200 times 8 minus c. Now, there are two ways you could solve this problem. I'll go ahead and just do both ways, but I'll let you guys kind of decide, which way you would probably want to use on the test. So I'm just going to write the problem down again. I'm going to solve it twice. It's kind of up to you how you want to do it. The first way I'm going to solve it is, since 200 is being multiplied to my parentheses, I'm going to divide both sides by 200. That way the 200 will go away, and I'll have only the 8 minus c on the right side, and 400 divided by 200 is just 2. So that makes a pretty simple equation to solve. When you subtract 8, you'll have negative 6 equals negative c. And when you divide by that negative, you'll get 6 equals c. So that's one way to do it, where you just divide that 200 off. The other way you can do it is you could distribute this 200, right? This is the more conventional approach, one that I think you guys would probably use. So the equation would be 400 equal to 200 times 8, which is 1600, minus 200 times c, which is 200c. So, and then solve this equation kind of like normal. So subtract 1600 on both sides. That's going to leave you with negative 1200 equal to negative 200c. And then since you want to get rid of negative 200, you can divide by negative 200. And you'll get c equal to 6, because negative 1200 divided by negative 200 is 6. So you get the same answer either way. I'll let you decide which approach you want to use. If you want to use the approach I did on the left here or the approach I did on the right here. It's kind of up to you which way you would probably solve it. But there's kind of different things you could do. Okay. But if it helps, plug in that 6 to see if everything makes sense. All right, in the last problem, we have the formula A equals 1/2 times B times H. That's 1/2 base times height. This is our formula for a triangle. Okay, now it tells us the area of our triangle is 24. So I'm going to plug in 24 for my area. 1/2 is always a part of this. It tells me the base is square root of 3x plus 6, and it tells me the height is 8. So I'm gonna put 8 here, and I'm gonna put the square root of 3x plus 6 here. I know it's base times height, but it doesn't really matter the order in which I do base times height. So I'm just gonna put the height first and then the base second. But there's a reason I'm doing that. But hope I didn't confuse you there. I'm just plugging in everything so far. So I plugged in 24 for A, I plugged in 8 for H, and I plugged in this for B. So the reason I put the 8 here is because I can do 1/2 times 8 right away. 1/2 times 8 is 4. So I'm just going to go ahead and put that as 4. So we have 24 equal to 4. And then don't forget times 3x. Square root of 3x plus 6. So remember, this is like a normal radical equation problem. So remember, you take care of the outside stuff first. So outside the radical is the 4. I'm going to go ahead and get rid of that 4. Since it's being multiplied with my radical, I'm going to divide by 4. That's going to make this equation 6 equal to the square root of 3x plus 6. Now, since there's nothing outside the radical anymore, I'm going to get rid of the radical. So that squares both sides, and that gives me 36 equal to, the radical is going to go away, so it'll just be 3x plus 6. Let me move this over here. 36 equals 3x plus 6. So solving this equation, it's standard equation. Subtract 6 on both sides. That makes the equation 30 equal to 3x. And then you divide by 3 on both sides. And we'll have 10 equal to x. All right, so basically, The setup, the only thing that you really have to worry about with the setup is, 1/2 times 8 in this case. I think we all kind of know that. Half of 8 is 4. But everything from this point onwards is just a normal radical equation problem, stuff we did yesterday or today, whichever, depends on when you're watching this video. But like numbers 13, 14, and 15, it's kind of like those. So I hope that you can do that. The setup part is where you really need to pay kind of attention. Okay. All right, that's going to be it. That's the review. That is the test that's tomorrow or today, whatever you're doing, okay, whatever you're watching this video. Go back, rewatch any of those problems you want to. If I didn't explain it very well in the video, just ask me on a remind or whatever. Okay, but I hope I did the best I could. All right, I'm going to leave it there. I'll see you then later. Have a good time. Good luck on your test.